Okay, wait a minute. Okay, so before the break, we look at this particular example. So what I show you here is that I can using the JavaScript object notation to represent an individual activity, such as a reaction or such as a new comment or even a new post. But I should be able to represent the new updated portion about the information. And then I should be able to send it to somewhere which they will perform an action called merge. They can merge or update the, the final version of the content with the additional information. And the second part is that this architecture should allow multiple such updates to occur in a distributed sense. So we don't have to say every time only one person can add a comment, that only one person can add a reaction. But all of us can do this simultaneously, and then we just need to update to the server with whatever we want to add it, and the server's responsibility is how to merge or combine all such effort together. So typically, you have to think about in a large scale system, such as Line, such as Facebook, such as Twitter, it cannot guarantee. Okay, this is what we call consistency. What do I mean consistency? Okay, let me actually mention this concept called data consistency. So what do I mean by data consistency? Let me actually write it down. Is that every user will see exactly the same thing at all time. Of course, this is after each update. Okay, let me explain this, what I wrote down here. I said every user should see the same thing at all time after each update, which means that if, just example of Facebook, the consistency means Facebook has 2 billion users. That means either this 2 billion user will all see your new reaction, or none of them will see your new reaction. This is like a nothing or all. This is called consistency, right? Consistency means that if you think about that, there is the piece of very critical information. I want to guarantee either all the student will see it or none of you see it. So this is consistency is very expensive because I want to guarantee that the whole community, 2 billion users, will see exactly the same thing. So most of the distributed system cannot implement this kind of, I call it strong data consistency. Sometimes there is a term, if you learn later, called asset property. Okay, I'm not going to teach you about what is ASIC property. ASIC stands for atomicity, consistency. What's I stands for? D. D is duration. Okay, so there is an asset property. Most of the distributed system is talk about much weaker consistency, meaning that eventually everyone will see the same thing. But temporarily, we're going to see something different. Okay, this is much more practical, right? So, which means that we all submit the update that eventually say nobody make any more update, nobody click any more reaction or anyone add any new comments. Then after that, for a period of time, then everyone will see the same thing. So eventually, but temporarily, we're going to see something different, which is more practical because you did update, I did update, and your update, I won't see it until, and in fact, you know, when you use Facebook, even use Line, that you have this property. That's because engineering, which is hard to make it happen, but this is a very practical. We just want to have some kind of weak consistency. That's there is a theory, by the way. I can probably spend more time to talk about. There was a mathematical theory about a clear definition about what is a strong consistency, what is a weak consistency, and how do you check or prove your implementation is actually follow one of this. Okay, if you're interested, I can tell you that, but this is not definitely not the coverage for EE1520. Okay, so we're going to do weak consistency. I'm going to tell you how you can do it now. Okay, and then I'm going to first tell you how to do that, and then we're going to see how exception handling is a key part in order to make this to happen. All right. Wait a minute, did I share my screen? No? All right. Sorry, you're going to hear me talking and then without seeing the things. Okay. For video recording, I'm sorry. Now this is what I was talking about. Okay, strong data consistency and weaker consistency. Okay, hold on, I'm not doing too much of that. Okay, so I'm going to pull back to talk about this. So I'm going to, in order to do this, I'm going to start to represent a different concept. Oh, I realize I have to, I have to change something here. Sorry, give me 1 second. Okay, so we're going to do this two-way street. This is an older slide and the function signature is a little bit different, but I'm going to do a later why I have this on the screen, but I don't think I need to worry about that for this moment. I want to move this down here. Okay, so that's good. Okay, so we have talked about the concept of dump to JSON. So dump to JSON means that I have a C++ object. I can actually convert it to the JavaScript object notation, which we have done this a lot. Hopefully, right now you're familiar with the concept of dump to JSON. So now we're going to do the other way. The other way means that if you have a JavaScript object notation object, I want to automatically convert it to C++. So two-way street. So if you can do this, then essentially it's very, very convenient. I mean, for example, I mentioned that I want to move an object from the bus to the NCKU hospital. What I can do, I mean, remember, those two are two different servers. So what you need to do is that you have to do dump to JSON. For example, you want to make a person, that person is a EE1520 student. You want to make that student doing dump to JSON. So you create a JSON representing that student in homework assignment number 2. And then you will send this JSON using remote object or proxy object to the server representing NCKU hospital. And then once the JSON is on NCKU hospital server, then you will call JSON to object, which you convert that JSON back to a person, C++ person object. So essentially what we're doing, you can use, if you have two, you can do dump to JSON and JSON to object. So by the way, dump to JSON is converting a C++ object to JSON object. And JSON to object means that you convert a JSON to a C++ object. If you can do this two-way, then essentially you can move object around to do homework 2, homework 3. By the way, homework 3 will be relatively light because I'm going to give you some piece of code which is similar to your homework assignment number 2. But that piece of code will have JSON to object, which has both way. So previously, I only give you halfway, but now you're going to have a both way. But you're going to see, I'm going to ask you to construct some JSON object, which you will be able to trigger the feature for the C++ object. And homework assignment number 4 is similar to number 2 and number 3, but look at how you can start construct a system which will help you to finish your final project. Okay, so we're going to, when you do your homework 2, homework 3, interactive grading, we will reserve time to talk about your final project, which is leading to homework assignment number 4. Okay, so now I'm going to show you the real code to see how these two pieces are working together. Okay, I need to, I already share my screen. So I'm going to bring my, okay, let's look at our class, but let's look at GPS. So GPS is always the easiest target. So inside GPS, we have two virtual function. One is called dump to JSON. So dump to JSON take no argument. It will return a pointer to a JSON value object. So that's convert a C++ to the JSON format. And on the other hand, JSON to object, as I mentioned, it takes only one argument, which is a pointer to a JSON object. And then using JSON to object, I'm actually going to update the value of my GPS object. So think about what's happening is, if you think about what is a C++ GPS object, is essentially only two attributes, which is a latitude and longitude. And your JSON representation of your GPS object is also two key value pair, which is a latitude and the longitude. And therefore, the JSON to object is essentially just extract those two values from your JSON and assign the value to your C++ latitude and longitude. So let's take a look at the code. Okay, here is JSON to object as a function. So I'm going to skip a few things, but just look at the input. The input is a pointer to a JSON value and return nothing. It's a void. So you can see immediately you start to see exception. I'm going to skip the exception part because the exception part could be complicated, but you have a bunch of a piece of code that's related to EE1520 exception, as I mentioned to you earlier. But the important thing over here is that I'm going to, this part is all about except. By the way, everything above this line is about exception. If you finish checking the exception, then you can see that this one is what I did. I said this latitude, this is the attribute. This latitude is equal to what? JSON. This is JSON. And then because it's a JSON pointer, so I need to put a star to kind of retrieve the real JSON object. And then I pulled out the latitude key. And then in the JSON, I have to because I'm expecting latitude is a double, so I have to use dot as double. So okay, this part is probably new to you. This is you probably first time you saw this, but let me tell you, this is about how do you actually do JSON programming. So what the left hand side is how do you in a program extract a particular key value pair and convert the right hand side of the column in that key value pair into a particular value you want to do. Okay, so this part is okay. I extract the whatever the right hand side using this portion. So let me actually do this. I want to explain to you what I did here. So there's two parts, number one and number two. The first part is just trying to get the key value pair. The second part is trying to convert the value in the key value pair into something which I can use in C++. Because the C++ latitude attribute is a double. Therefore, I want the value I can get from the JSON is also a double. So I can actually get that to work. Okay. And this part is just checking if the latitude is greater than 90 or less than minus 90, I will set it to be 0. Okay. And then similarly, I have the same piece of code. Looks like here. This is exactly the same like what I have earlier, except this time is from longitude. Okay, it's the same thing. I'm actually extract that key value pair, longitude, and then convert that value into the data type, which is double that I want in this context. Okay, the rest of the code is all about exceptional handling. So you can see that the real code in this JSON to object is only like a 2-line. But the rest of the 40 line is all about exception handling, which I will teach you why I need to do that. Okay. All right. So this is a GPS. So I'm kind of using a very simple way of tell you the simplest structure about JSON to object. I'm just extract the value from the JSON and change the value of the current object. So I can actually recover the information about a C++ object from the JSON. Okay, any question? Okay, so now I want to do a little bit more complicated example before I talk about exception handling. I want to look at label GPS. So again, label GPS also have JSON to object. Pretty much every single class that in this system I designed, they all have dump to JSON and JSON to object. So you should expect that. Okay, so in the label to GPS, I want to tell you this. You see what I did, two things. Because it's inheritance. Because it's inheritance, I actually want to call the input is still the same. Okay, the input is homogeneous, is always JSON value. And is a pointer to a JSON value. And therefore, the first thing I want to do is leverage the inheritance relationship. I want to call my base class, which is a GPS DD's version of JSON to object. So you see that the first part I highlighted here. I hope you can see it from your screen because the projector screen looks horrible. So you can see that I'm actually calling JSON object and using the same argument, but I actually have a GPSDD colon. This is actually like a casting. I force this JSON to object to call my base class. So I basically is going to pass the control to call the function I showed you like 1 minute earlier. Okay, so this inheritance work perfectly well with JSON to object. I just call it. And after I finish calling, and you can see here, I have a bunch of exception related stuff. And eventually I call this line. Because what's the difference between label GPS and GPS is about the label. And that we have an extra label attribute in the label GPS class. And then again, I'm actually extracting the label key value pair. Let me do this again to show you the two-step. Okay, the first step is basically extracting the label key value pair. And the second step is convert the return value into a string, because now there is a difference between latitude and label, because latitude is double, but label is a string. So that's why I actually have to use as string. Okay, so this is about JSON CPP programming that you can use all this function to actually convert the value very nicely. So by doing this, in fact, you will see that the whole JSON to object for label GPS is really have a two line. The first line is about calling my base class JSON to object. And the second line is actually calling the label portion about this object. So it's only two lines. The rest of them are all for exceptional handling. All right. So I will explain to you why you need all this exception handling. But right now you see that JSON to object is I just want to convert that. Okay. I just want to do the conversion from the JSON back to the C++ format. Okay. So now I want to tell you one thing. I hope I can see this here. I would say JSON value. If you go to the GitHub JSON value page, you can do a search of JSON value. This is JSON CPP. It will actually tell you the class JSON. We have been using JSON value a lot, but now I want to tell you this is all the detail in the .h file. In the .h file, it talk about all the public attribute, but it talk about all the public member function. And take a look at the member function. This portion is all about constructor. It has a lots of constructor and one destructor. It has the operator overloading for assignment, and it has all the operator overloading for other things. But then you see it has all the as function. As C string, as integer, as unsigned integer, as integer 64, unsigned integer 64, as a largest integer, largest unsigned integer, as float, as double, as bool. Okay, you can see that the JSON value has all the member function that allow us to do all kind of conversion. I only use two of them, as double and as string, in my example earlier, but in general, you can convert to anything. And then there is another thing which is important is that this part is conversion, but the other part is called checking. I want to check a key value pair. I mean, before I do the conversion, if I want to convert to a string, I need to see if it's really a string, because it could be I thought it's a string, I want to do as string, but it is not. It is actually something else. That's why I have a Boolean check. I can say is null or is a bool, or is integer, is unsigned integer, is double, is a string, is array, is object. I can have a bunch of member function under JSON value allow me to check the data type on the right-hand side of a key value pair. And that is very important. Okay. You might be wondering that why JSON value has to provide so many member functions related to checking the data type or conversion the data type. Okay, listen to me very carefully here, is because JSON and C++ representing two different extremes in terms of handling data. Okay, this is important. C++ is something we call a structured data, meaning that you have to define each of the attribute, whatever it is, and you give the type about what that is. And JSON, on the other hand, it doesn't really have a compiler to actually check the value because it's a weak type system. It's sometimes JSON, we call it unstructured data. I mean, if you handle data in the later, when you want to deal with a real application, you have something called structure versus unstructured data. Let me actually check whether I can do a Google. Structure, RUCT, structure versus unstructured data, the first one. Okay, you can actually take a look. What is the structure versus unstructured data? Basically saying that one of them is predefined. You predefine everything. Usually it says something about JSON somewhere. What is the structured data? Can I get rid of this? And what is unstructured data? Yeah, okay. I'm not going to find it, but usually somewhere down there. If you see every time people talk about unstructured data, that eventually it will fall into a JSON. Okay, for example, you have all kinds of email, social media posts. This is all about unstructured data. Unstructured data meaning that it doesn't have a strong type compiler to check. And therefore is a programmer's responsibility when we want to convert a unstructured data into a structured data. I would do all the check. Okay, so that's why the difference between JSON and C++. Unfortunately, there is a critical difference that we need to deal with here. Okay, all right, so now I'm going to look at the exceptional handling code. I hope you now understand the basic. Let me show you one thing, which is even more extended before I show you the exceptional handling code. I want to look at post.cpp, which is the one example I showed you earlier. So this is the post, the most complicated thing. You see that I have a reaction and comments and created and everything. And I have a JSON to object. Okay, you see that I have a JSON to object. And then the first thing is the input is this argument. And then the first thing is ID. This part is still exceptional handling code, but I want to extract non-exceptional handling code for you. I have a lots of exception handling. Wow, it's a lot. Wait a minute, where's my ID stuff? Yeah, this part is a set ID. This set ID to the ID string. That's one line. Okay, lots of exception handling, but there's one part setting the ID part about this post. And then I can set the from, who actually did this, who is a person, what is a person. I have an author. You see that I actually not calling myself, but this is I calling a author, which is a person. I actually do the JSON object from. I extract the from key value pair and then try to do that. But let's look at the comments because comment is the one we showed you earlier. Okay, this part I think is the comments. Okay, this part is the comments. You see that what's happening? This is exception handling. Okay, this part you start to see the comments. This is still exception handling. Here, you see that? This part, I'm actually calling the JSON to object, but looking at the comments. Okay, each of the comment, I'm going to call JSON to object. And then this is going to lead to the comment.cpp JSON to object. It's all follow the same interface, but inside the JSON to object, it has ID. Remember I said there was a 3-part ID, and then has a from, and then it has a message. And the one I really want to show you is reaction. Created, after created is reaction. Okay, inside the comments, I have a reaction. And inside the reaction, I'm calling here. Okay, here is the one. I'm actually calling L reaction pointer to the JSON to object on the reaction object. Okay, so you can see that it's a multiple level. From the post, I actually call comment. From comment, I actually call reaction. And now I want to go to reaction.cpp. Again, JSON to object. So inside the JSON object, I'm handling only the reaction part. And then you see a lot of exceptional handling code. And then inside the reaction, I basically call the person who, the time for this reaction to be created. And then inside, I put who actually delivered the reaction. I use author JSON to object. And then I think and that's it. That's everything I have to deal with. Wait a minute, there must be one for type, reaction type. Where's the reaction type? The reaction must have a type, otherwise I'm very shaky. Yeah, type is here. Here is the type. Where is my reaction for? Oh, type is here. You see that? This part, this type. So reaction type is the same thing. I have 2 parts, as I showed you earlier. The first part is about extracting the type from the reaction portion. And the second one is because the type is a string. So I actually to extract that, and then I can get that. So it looks really complicated, but it's actually being separated into each of the function, each of the class recursively, and each of the JSON to object, they only handle a little bit about that portion of the information. And then the whole system will work naturally. The only thing that might scare you is all the rest of the code. The rest of the code is all about exception handling. By the way, the bad news is it looks like 99% of the code is something which you don't understand at this moment. And I told you it's about exceptional handling. But the good news is that all the rest of the code is very template. It looks like a template. They're following exactly the same style, exactly the same reason, exactly the same syntax. So those things you can think about as a template. You can just copy and paste from other JSON to object and to do that. Okay, so now I'm going to use the rest of the 12 minutes to talk about the design of the exceptional handling in the context. So Control X, Control C. I'm going to use the GPS as a first example, then we're going to make it bigger. Okay, so now we're going to look at this code. I want you to don't worry about this part first. Okay, don't worry about this part. This part is actually, I want to say the first 4 lines I'm going to put in here that are highlighted in your screen. Don't look at the screen, the projector, but look at the screen in front of you. All of the JSON2 object has this 4 line. Okay, let me just show you in case you don't realize. If you go to label, let me go to post GPS, post.cpp. You see that? This is a post JSON to object. It has exactly this 4 line. 1, 2, 3, 4. The only thing that's different is this function I call a JSON to object pre-check. Inside this pre-check, only the third argument, which is representing a flag, saying that, okay, this pre-check is checked for JSON to object for post. And this one is the pre-check arrow flag JSON to object for GPSDD. Only this two, the third argument is different. The rest is exactly the same. Okay. So it's pretty much a template way of treating this exceptional handling. Okay, so don't worry about this 4 line, but now I'm actually going to talk about the most critical line. In fact, you understand this few line, you understand pretty much why we're doing this. Okay, so the thing is that, remember I said, I try to convert a JSON GPS record into a C++ GPS record. What was the question you need to ask first? Is that whether that JSON object, they actually have the right information. Remember I said C++, you already have a compiler, but JSON, you're actually getting this from the internet, and they might not doing all kind of check. I mean, it could be they do not have a latitude, or maybe there is a misspelling about latitude. It's not latitude, it's littitude. They add another T because of the typo. So the first thing you should check is that whether you have a valid JSON for you to convert into your C++ object. So in this case, naturally, the first thing you need to check is whether you indeed has a key value pair that you're expecting. In this example, in the GPS, I'm actually expecting you have a latitude and you have a longitude. So that's why that's the first thing. You need to have this too. If you don't have this too, forget it. I'm not going to do the rest because I'm going to causing my my C++ object into big trouble. So that's why you need to check. You need to check. So how do I check? You see that I'm actually checking using the function I just showed you earlier on the website. Is I'm actually check whether this, when I do latitude, I use the function is null. If is null is equal to true. If is null is equal to true, what does that mean? Meaning that, hey, you don't have this key value pair. You don't have this key value pair. Missing key value pair latitude. Okay. And the second part is I'm actually checking, okay, if you do have the key value pair latitude, I want to know whether your latitude, the value, is a double. So I said, that's why I use another function called is double. So the second part is the value is not double. Okay, that makes sense, right? I want to check the JSON you throw to me that I'm going to convert it to a C++. By the way, this is important. You think about somebody submit an update for clicking a reaction. If they actually put in the incorrect information, you're going to corrupt a big system such as a Line or Facebook. And therefore, you need to perform the necessary check when you receive the JSON from 2 billion users. You have to check it. And in order to make sure your code is correct. So these two are checking a particular key value pair. So by the way, you look at 99% of the JSON to object from all the classes in this directory is performing check like this. Because if you don't check, then your system won't be stable. This is a very important. And therefore, if this check failed, that's why this two statement, if either one of the condition is met, then essentially this is the exception. Then the rest of the code in this pair of bracket is just basically generate exceptional handling information. That's why I'm using EI, exceptional information. By the way, EI stands for exception information. I'm actually going to create exception information, and then I'm going to eventually do, okay, I didn't do a throw. You see that? I didn't throw anything, but instead I actually collecting all the exceptional information into a vector. So I'm actually collecting the exceptional condition into a vector, which is represented by a variable called LV exception pointer, which is LV exception pointer is one of the first 2 or 3 lines. You see that here? I have an LV exception and I have LV exception PTR, which these 2 lines are the same thing. Okay, one is the pointer, one is the object representation, right? I actually have that. And that's why I call EE1520 exception. And at the end, after I did all the check, at the end of each of the function, I did what? Throw. I said, if this LV exception pointer of the info vector has size that's not equal to 0. If it's equal to 0, size is equal to 0, what does that mean? It means that I didn't raise any exception. If I actually have at least one exception element in the info vector, then I'm going to throw the exception. So you see the code is this structure of the code for all the JSON objects. I'm checking every single element and I'm collecting exception. And then I throw the exception at the end of the JSON to object. Okay. All right. So let's go back to look at this code again more carefully. So you can see that this part of the code, I'm actually just checking that whether you have latitude, this whole piece. And then I basically encode different flag, whether this is you missing the key or the key value type. The type is mismatch. And then I basically push using pushback, which is the routine associated with a vector in C++. I push that EI pointer, which is the exception information pointer, into this exception pointer, which I have. Else, meaning that this particular check, we don't have encounter any issue. So that's why I did this part. I actually assigned the value into the latitude. And similar thing happened again with longitude. The longitude is the same. I have to check whether it's null or it's a double. And then I basically do the whole thing. And then push back again. So you can see that check. If I have an exception, push back. And then at the end, I throw. Okay, that's the template for exception handling in this routine. Okay, so now let's actually take a look at another one. Let's go to label GPS. So it's the same thing. Remember, our good friend has the 4 line. 3 lines is trying to define EE1520 exception, and another line is doing a pre-check. But the pre-check has a only different flag. The only part here is that, okay, I have this. I call the GPS JSON to object, which is the one I just showed you. But over here, what I did is I have a try and catch clause. So over here, you see that I'm actually so the code I show you will throw all the exception that's being catched by being caught by the GPS DD level. And inside the label GPS, I actually using this catch to catch the one that that from the previous level. But then what I did is I append this to the LV exception pointer. So essentially, I collecting over here. What I try to do is I try to collect both the exception condition being generated by this particular class, which is a label GPS, but also I combine the exception that's actually being raised by my base class, which is the top. So you see that why I'm actually doing this processing of JSON to object, I'm converting this piece by piece, but I'm also collecting exception information piece by piece. And over here, you can see I'm doing the same check. I'm actually checking the label. Is null, is a string. This part is the same thing. And again, you will have a pushback over here, info vector. And then if not, I'm doing this. And it's also at the end, exactly the same. If the size is not equal to 0, I'm going to throw this. Okay, so everything is very standard. Let me show you one more example, then we're done. Let me use comment. Okay, inside the JSON to object, again, there's a 4 line. Okay, it's always the same. And then there is an ID. I have to check the ID, and also I'm doing a pushback. But then let me see the reaction part. I want to show you because comment is going to do reaction part. Let me do from. I think from is fine. You see here? This is I'm processing the author. I'm using the from. I'm doing the JSON object from. I'm actually calling the person JSON to object. So that one potentially will encounter some problem like missing an important attribute. So over here, you see that once I got their E1520 exception, I append. I basically just append their exception into my own exception. And the same thing for, let me do reaction, just one more, and then show you the structure of the code. This is created. Reaction. Okay, reactions here. You see here is a reaction, and I have a try clause, which is for the reaction JSON to object. And inside here, if I handle reaction, I have some exception. I actually doing append. So I essentially accumulate every single exception and handle every single part of the JSON. And at the end of the code, is always the same. You're expecting the same thing from every single JSON to object. At the end, it's check if the size is not equal to 0. I'm going to throw this one. Okay, so I'm hopefully showing you probably the most complicated C++ class in their design in JSON object in the same directory for our class, and the simplest one, which is GPS. They're identical. The structure is identical, always 4 line, and then always throw at the end. In the middle, we'll just try to check whether you have the right key value pair and the data type. Okay, so we're going to done. I'm done here, and then I have 2 announcements. Maybe I should finish recording first, and then I will tell you what I want to do.